different types of solid carbide Endmill were tested with different feed rates to obtain the surface roughness value, and the results were analyzed. The aim of this experiment is to test the capability of two different solid carbide Endmill with wiper geometry and without wiper geometry to achieve 0.035 micron for the surface roughness value. There are two objectives in this experiment. The first objective is to optimize the efficiency in manufacturing products with high quality. The second one is to obtain a good surface finish. There are two factors that affect the cutting process. The first one is the cutting tool with wiper geometry. The second one is the conventional non-wiper geometry cutting tools display an asymmetrical surface finish. A tool bit with wiper geometry is a tool bit where the nose of the edge have main radius with a few smaller radius compared to the conventional cutting tool where it only has one radius. A tool bit with wiper geometry produces a better surface finish in metal cutting machining. The wiper performs by wiping away the minuscule peaks and valleys that present on the material surface. There are a few factors that affect the surface finish, such as the cutting geometry, the type of material of the workpiece, and the cutting parameters, such as the feed rate, spindle speed, depth of cut, tool diameter, tool step over, and tool overhang.
Methodology for the experimental work. It begins with tool setup, carried out run-out tests and create the cutting program. Then, proceed with roughing process. The boxes at the right side show the parameter used for the process. A flat end mill with 20 mm diameter, 8000 rpm, spindle speed 600 mm per minute, feed rate and 10% step over is used to cut 9.9 mm depth of the workpiece. Next, do the finishing process. Finishing process done with various tool overhang, which is 40, 50 and 60 mm, using flat end mill 10 mm diameter with 8000 rpm, spindle speed 600 mm per minute, feed rate 30% step over. The depth of cut is 0.1 mm. Lastly, do the surface roughness analysis by carrying out the surface roughness testing and surface roughness image capture.
The findings that we got in this experiment, first is the percentage difference between the wiper and no wiper tool bits. Second is the surface roughness value that we test on the surface finish after the machining process for x-axis and y-axis. The results of the percentage difference between wiper and no wiper tool bit can be seen in the histogram chart here. The highest percentage reading of the surface roughness value are 91.2% at the tool overhang of 60 mm on the y-axis. The results for wiper insert tool bit in this experiment also shown that as the percentage difference increase, the surface roughness of the surface finish after the machining process also will be decreased. We have successfully achieved our aims in this experiment, where we have achieved the surface roughness value of 0.035 micrometer at overhang 50 mm for wiper insert tool bit. The after machine product of the wiper tool bit can decrease and improve the surface roughness compared to the no wiper tool bit surface finish. In this experiment, we also found that the surface finish after the machining process with the no wiper tool bit with a higher tool overhang will increase the surface roughness as the tool bit will vibrate during the machining process.
As for a conclusion, surface roughness decreased with tool overhang of 40, 50 and 60 mm by using tool bit that have a wiper. The best option to use the tool bit that have wiper as it enhances the finishing process. And lastly, the tool bit with wiper should be implemented in industry as the expected result achieved is 0.035 micrometer.